It's terrible, terrible penmanship. Right? So that's one particular situation where a function is not differentiable. Now there are others that I want to go through too. A new page on here. So we could actually classify situations where a function is not differentiable by 4 different types. The first type is in a graph that might look like this. Well, maybe not exactly like that. It's going to drive me crazy. Jeez. It's killing me. It's killing me. All right, anyway. Don't draw the axes up there. So if I get a picture that looks like this, we'd say that this particular point where it comes to a sharp corner, we classify that as a corner. Now, corners are places where functions are not differentiable. Okay? And the reason basically is that the left and right-sided derivatives are not equal. So let's say this is absolute value x. Here the slope is -1. Here the slope is +1. And at this particular point, you know, what's it going to be? Is it -1 or +1? And so at that particular instant, it's actually neither. There's like a confusion. As you come from the left and as you come from the right, those are not the same derivatives. Okay? So we call that kind of situation a corner. Another shape of a graph is this. This is called a cusp. Now a cusp is a particular situation where the left-sided derivative is infinity. So as we come from the left, notice that we get a vertical tangent line. So as we come from the left, it's basically straight up and down. So that's approaching, notice that these are all negative slopes. So technically the slope is approaching negative infinity. And as you come from the right, these are all positive slopes. And as you get close to the cusp, those tangent lines go vertical again. So this is actually approaching positive infinity. So the left-sided derivative is negative infinity. The right-sided derivative is positive infinity. Whenever that happens, that's called a cusp. So it kind of looks like a corner. But whenever you have a graph that comes to a sharp edge like that, that's going to be a place where the left and right side derivatives are not the same, which means that the function's not differentiable. Okay, a couple other situations where we say the function's not differentiable, and that is if you've got a situation like this, where at a particular instant, make that nice and big there, at a particular instant, let's say the graph goes vertical. Okay, so if we have a vertical tangent, that's another situation where we'd say it's not differentiable. Okay? Because, and the reason in this particular case is not quite the same. Here, the left and the right sided derivatives are equal. Okay? Even if the tangent line goes vertical, from the left and from the right, we're still approaching the same value of positive infinity. But here we say that it's not differentiable because there's not a finite answer. The answer is infinity. And so, you know, that's not a slope. Okay, it's basically undefined slope. Okay, so that's technically a place where it's not differentiable. And then the last situation is, like, for example, if I've got some graph that looks like this. You know, at this particular point, let's say that's point I call C, the graph is not continuous at that point C. So at C, we'd say that it's also not differentiable. Okay, so the last classification is a discontinuity. And sorry for the penmanship. So whenever you have a function that's discontinuous, that's holes, that's jumps, that's asymptotes, in all those situations, it doesn't make sense to even talk about the slope of a curve because the function doesn't even exist there. Okay? In this particular case, it might exist at C and have this value, but obviously the slopes as you come from the left and right aren't the same. So anytime you have a discontinuity, it's never going to be differentiable. Okay? Now, in general, we can classify these concepts with a general statement. It goes something like this. Discontinuity implies, that's what that symbol means, non-differentiability. Okay. Which basically means if a function is discontinuous, it's going to be not differentiable, period. It's not even possible. Okay? Now there's another related statement that's also true. If a function is differentiable, differentiability implies continuity. Again, this makes sense because if a function is differentiable, that means its derivative exists. If its derivative exists, that means it has a slope. If its slope exists, then the function has to be continuous, or else it doesn't make sense to talk about slope. So those are a couple of statements that are always true. Okay? So there's some basic concepts. Let's talk about some problems that you guys will have to do in the homework. The most basic type is just going to be, here's a function, find out where it's differentiable. So for example, let's take a look at this one. F of x equals cube root 3x minus 6 plus 5. Okay. So let's take a look at the graph of this and see if we can classify. The question is going to be asking you, where is this differentiable? Okay. So let's take a look at the graph. So it is cube root 3x minus 6 and then plus 5 at the end. I'll just start with the zoom 6. Hopefully that'll be what I want. Okay, now just by looking at the graph of this, you can kind of come to the conclusion that there's a vertical tangent. There's a spot right here where the graph instantaneously goes straight up, okay, before it starts to decrease its slope again. Now later on we'll be able to more easily prove that the derivative there is undefined. Right now it takes all that limit stuff, which is kind of a pain. You know, it's fun and exciting, but it's also a little bit of a pain. So next class we'll start teaching you some shortcuts to find derivatives. But for right now, we can just kind of analyze the graph, and you can see that the slope goes vertical right at this point. It's at x equals 2. There's also a command in your calculator to calculate dy dx, and dy dx meaning slope. So I can calculate the slope, and notice if I plug in x equals 2, well, I guess it didn't give me what I wanted. It's telling me the slope right there is 144. Which is very steep. So I guess I thought maybe it was going to tell me it was an error. So forget I did that. That really didn't help at all. Anyway, the tangent line does go vertical right there. But everywhere else in the graph, there's no issues. Okay, there's no discontinuities anywhere. There's no other places where you can see a corner or a cusp. So we'd say this function is differentiable everywhere except for at x equals 2. Okay, so going back to the problem, my answer for this